So let's start with going, first of all, see this. Know that. Second, here's what we're going to be doing. Here's something you want to be able to answer by the end of the next half hour. What is the difference between the solution of a system of equations and the solution of a system of inequalities? Equations obviously have equal sign. Inequalities have less than, these signs. So next paragraph, how would you answer that question? From last night, something emphasized over and over, you will check your solutions of inequalities by what? Plugging in 0. Yeah, plug in. Yeah, 0, 0, or just something in the shaded region. Any point in the shaded region. For sure. So when you have something like this, and shaded right here, pick a point in the shaded region to plug in, and you should get something true. You should get something like 0 is less than 10. That means it's true. It means it is an answer. Remember, shaded regions all your answers. Always be plugging in. We'll be doing more of that in today's one. Do not skip that one. You want to make sure things are correct. Okay, so again, we're just going to practice this Algebra 1 standards. Practice solving systems of equations and systems of inequalities. Something that's going to be new though is right here. Okay. Got to be able to explain the differences, not just say what's the answer, but explain what's the same and what's different. It's not critical thinking. Also throw in some vocab that you'll need to know as well. But the majority of this is going to be Algebra 1. We'll focus on doing everything correctly, neatly, make sure you get every graph correct 100% of the time. Okay, we'll review. 4 equations. 4 equations right here. Equations only. Slight differences with inequalities, that's what you're going to keep in mind. 4 equations, you have 3 possibilities. You can graph 2 lines 3 different ways. First way gives you one solution. Second way, you get infinitely many. This is like if the 2 equations are identical and I graph one, it looks like that. And when I graph the second one, it happens to be the exact same line. Then you have infinitely many solutions. And then, of course, if you graph 2 lines and they don't intersect at all, you have no solution. So, for equations, solutions are intersections. One intersection, one solution. Intersects everywhere, infinitely many. Doesn't intersect at all, no solution. The solutions are intersections. So there are 3 possibilities. Now we're going to give these some special names right now. I'm just going to give you special notice for this. And it has to do with these labels. Can you tell if a system is consistent, inconsistent, independent, dependent? You can go to your textbook on page 118. And there's the definition. Page 118 if you want to take notes on that. System of equations is consistent if it has at least one solution. And inconsistent if it has no solutions. Consistent system is independent if it has exactly one solution. And dependent if it has an infinite number of solutions. So here's everything you need to know in paragraph form. I'm going to go ahead and redo this, but as like a flow chart. Might be a little bit easier to follow. take note. It's on page 118. So, characteristics. System of equations. Right? So there's two possibilities. System. And then, of the consistents, there's two possibilities. One is dependent, and the other is so inconsistent was what? Yeah. Inconsistent was the no solution. What did the graph look like again? Parallel. Parallel lines. So you notice how there's three parts here. Inconsistent is linked with no solution, or empty set is linked with parallel lines. So if I gave you the parallel lines, could you tell me there's no solution is inconsistent? If I gave you the no solution, the empty set here, could I say, oh, draw me a graph that has no solution? Could you draw two parallel lines and say it's inconsistent? So given one, you want to be able to know what the other two are. And that goes for these as well. What do you have here? Dependent? What is dependent? Which one was that? Yeah, infinite number of solutions. Like, infinity sign. A little bit better. But you can also just write it out. Infinite solutions. Technically, there's infinite number of solutions. The answer is infinity, so infinite number of solutions. And again, graphically, what does that look like? The lines are the same. So if you graph one like this, and then the second line was the same exact line, they intersect everywhere. So the answers are the intersections. It intersects infinitely many times. That's why there's infinitely many solutions. And the last one is the standard one that we get most often. The answer is just x comma y. Now, where do these two lines intersect? So if we graph two lines, and where does it intersect? There you go. So this is just another way. It's basically the same thing that's on page 118. That's all in Word, but as you can see, that it's impossible to have an independent or a dependent and inconsistent. So inconsistent is kind of by itself, and no solution is kind of by itself. And then over here you have two possibilities: a consistent and dependent, consistent and independent. So tomorrow when you walk in the door, again, you should be able to take any quiz involved with this stuff. And show me a graph that has infinite solutions. Here's a graph. How many solutions are there? Draw me a graph that has an independent solution. What does that look like? And you can come up with these small steps. It's just vocab. It's very similar for like geometry. You just got to know your vocabulary. Good? All right. So, what I'm going to do, we're going to go through a few problems. It's going to be two parts. Of course, just to graph it. And then the algebra 2 part, the new part, just label it as consistent, independent, and so on. Okay, so make sure you read the directions and follow it and write this stuff out. There's a few people on the quiz that it said in directions, write the domain and range, and you didn't read it, you didn't write it, and you got it wrong, right? So make sure you follow the directions. You have to read them to follow them. You don't really need to write this down. It's going to be a lot of review. I want you to see the small things, small nuances. I trust you know how to get slope-intercept form. I trust you know how to rise overrun and all that stuff. For more examples, you can go to the book, and it'll give you, okay, here's an example that has one solution, therefore it is consistent and independent. Solution means the intersection. Intersects at 3, 4. Here's two different equations, but when you solve them with slope-intercept, you can see they come out to be identical. Identical. They look different here, but when you slope-intercept, they come out to be identical. So that means they look like the same line. So you have two different equations that just point to the same line. Consistent and independent. And then, of course, last one, same slopes, different y-intercepts, therefore they're parallel, therefore it's inconsistent. So these are the three different possibilities that I'll cover just a little bit. I'm going to point out a few things just so we don't make some common mistakes. Okay, so why don't you go ahead on your paper and just solve both of those for slope-intercept. Practice problem. Try it out, see what you get. Okay. Tell me, by using your clicker, what is the slope of the first equation? What is the slope of the first equation? Let's plug that in. What is the slope of this first equation? And a few more people. So again, make sure your number is dark. That means you put your answer in. Everybody except for 34. 19, 29. Good. Good. So this is how I kind of keep track of things. Yeah, slope is. So even though this is algebra 1, just notice how we can still make mistakes. If you got -2, that's C1. Write down, write down. Write down. So let's see how you can do this. I would suggest, if since you need to get y equals, why not add y to both sides? And subtract 4 on both sides. So now we have 2x minus 4 equals 1. It's okay to get y on the right-hand side, the same as y equals 2x minus 4, but sometimes it's easier just to add y to both sides if it's 1. Same thing on the second one. Right here. You can add y and subtract 2, and you'll have x minus 2 equals y. Good idea. So if you make a mistake, again, it's not going to be about, well, I didn't know how to graph, I didn't know rise or run. It's going to be something like that. Oh, I forgot a negative, so I got negative. So realize the mistakes are in the small details. You know, you've been adding and subtracting things to both sides for years now, right? But that's where the majority of the mistakes are. It's not the newer stuff, it's old habits, forgetting a negative. All right. So if we graph this, let's see here. Let's graph graph the second one. What's the slope of this one? 1. Okay, so go to -2. Up 1, oh, right 1. So on. Again, you can just watch up here. Solid or dotted?
Solid?
Oh. Solid. Equals. Good. All right. What about here? What about here? -4. Let me do that. So -4, go up to over 1, up to over 1. Grab that. The answer is. What's that? The answer is where they intersect, right? What's that?
0.
What?
0.
Is it, which one is it?
Consistent.
Yeah, it's this one. Consistent and independent. Is this the right answer though? How do you know for sure? Check. Plug it back into both original problems. They should be true. So 2 times 2 minus 0, is that equal to 4?
Yeah.
And is 2 minus 0 equal to 2? So 4 is equal to 4? Yes. 2 minus 0 is 2. 2 equals 2? Yes. So you know for a fact it's correct. You do this every time. Do not say I put 2 lines down. They're always correct when I draw lines. Always check. Equations, you check the actual point. There's an inequality with check the shape. Again, what was the most important step of all this? Yeah, it was this right here. I know we spent a lot of time on everything else, but none of this matters if it's wrong. None of it matters if it's wrong. It's the shortest step, but it's the most important. All right. Spending too much time. This is more than the same. More than the same. Let's see here. Let's ignore these equations for a second. And what if I said graph y equals 4? What does that look like? What's the slope? 0, 1, 2, 3, 4. Y-intercept is 0. Y-intercept is 4. Slope is 0. So it doesn't move up or down. Just for fun, what's the y-coordinate at all these points? 4. So the equation's called y equals 4. And the y-coordinates are all 4. Connections. Making connections. There's my lines. A little off. What about, what does x equals 3 look like? How about right here? What's the x coordinate of this point? What's the x coordinate of this point? 3. X coordinate of this point? 3. So the equation x equals 3 has x coordinates that are all 3. And it forms a vertical line. Forms a nice vertical line. There you go. This is a review on how to graph horizontal and vertical lines. Not forget. Let's get into the inequality part. Get into the inequality part. Here's where we have the solid, dotted, the shading, and things like that. A little more involved, so I'll spend a little time on it. Again, let's go ahead and solve this for y. And tell me, and we'll do shade. Let's say shade up, and B is solve that in a minute. And then if you think you should shade up on this, enter A, press A and then enter. If you think we should shade down, then press B and then enter. A or B, shade up or shade down. $30 seconds. You get an answer in? 29, 15, 16, 19, 14, 15, 15 and 20. All right. So 25 people. We want to shade down. 5 people you want to shade up. Let's see. What is it? So first use what? Subtract x on both sides. You have negative 2y. And then negative x plus 6. And then what? 9 by negative 2. And then raise the sign divided by negative. About 70% of you caught it. But just keep in mind, you guys will know how to graph all this stuff. If you make mistakes, that's the kind of thing it will be. It will not be like right in front of you in your face. It will be something you learned 6th, 7th grade. Oh yeah, you divide by negative, switch the sign. Always looking out for it, okay? All right, negative 3. And then up on them, solid it up.
Solid.
Got it. All right. Here. There we go. All right, same thing for the second one. Go ahead and solve that for y. Get it? Green. What do we got? 1/4 x. Negative 1/4, okay. X minus 1. What's the sign? Last time, yeah, stay the same because we didn't divide by negative. It's positive 4 this time, so no problem there. Good. Start at negative 1, down 1, right 4. And also move the negative to the bottom, so up 1. Solid or dash? Again. No? Alright, now for the shading. We got to shade part of this. So it's where the shading overlaps. So what points, now there's 4 different areas, let's not forget. 4 different areas. There's this area up here. There's this little area right here. There's this area down here. And there's this area over here. So every time you have 2 lines intersecting, there's 4 different areas. That's because if they're both positive, both greater than, they'll be in one area. If they're both less than, they'll be in an area. If they're one greater, one less, or one less, one greater. So this is why there's 4 different regions. There's 4 different combinations of inequality signs. Both greater, both less. Okay, one greater, one less, and then when you switch it around. So which is this? So you want to go below the blue line and below the green line. So below the blue line would be all this. Below the green line would be all this. So where is this both shaded? Area 3. All this. This is where it's below the green and the blue. Below the green and the blue. All this area. How do we know for sure? Check. What point could you check? Something in the shaded region, right? Don't use 0, 0. You got to check something in the shaded region. How about 1, 2, 3, 3? Let's go to 4. That right there is 0, negative 4. So when you plug it into the original inequalities, you get 2 true statements. And you'll know for a fact before you turn it in, you know it's correct or not correct. Know for a fact. And you could even do this check before the shading, and that way you want to shade it, then check, and then have to erase the shading and shade somewhere else. Do a check. I think it's this region 3. Pick a point. See if it's true. So is 0 minus 2 times negative 4, is that greater than 6? And is 0 plus 4 times negative 4, is that less than negative 4? Let's see here. We get negative 8. Is negative 8 greater than 6? Positive, yeah. Negative 2 times negative 4. So it's positive 8 greater than 6.
Yes.
And here, is negative 16 less than negative 4? Yep. We picked the right region. If we pick something from here, it'd be true for the green. It'd be true here because it's still below the green, but it'd be false for the blue because it's not below the blue line. It'd be above the green. If you picked a point in here, it'd be false for both because this is above both lines and you want less than both lines. We're going to do one more. One more practice. Anything different about this in the beginning? Watch for nuances, watch for differences. This is going to be correct? Yes? Yes. This is going to be what is it? 1/2 x plus 1 minus 1? What's that? Where's the sign? Because, oh yeah, that's a negative 1, and I'm dividing both sides by negative 1, so it should be. What about negative 1/2? Is that right? Should be 2? Positive 2, okay. And then what about here? Minus 2? Check all my work here. Technically 1, x plus, negative x plus 4. 1, 2, 3, 4, and then down. Solid or dotted? Like so. And then the next one is here. 2 over 1, negative 2, up 2 over 1. Solid or dotted. That's the kind of stuff that's going to be in your head all night. Solid or dotted. Solid or dotted. Where do I shade? So what is above the green line but below the red line? Above the green line, below the red line. We got 1, 2, 3, full area over here. So, go ahead. What area? 1, 2, 3, or 4? 1, 2, 3, or 4. We'll do 10 seconds. 1, 2, 3, or 4. See what you think. 5, 4, 3. There you go. Your hand. All right. Well, most people say area 2. Okay, so area 1. Area 1 is above both. That'd be greater than for both. This would have to be greater than. Area 3 is less than for both. They both have to be less than. So you see how this area is above the green. This is straight up with the green, but below the red. The red down. And this is where it's below the red, but still above the green. This whole area red. And again, check, check, check. You could even do that before you do the shading. So pick a point. If you said 3, you could plug in 2, 0. You can plug this point. You'll see it'd be false. It'd be false for the green one. It wouldn't work because it's below. Pick a point. Verify that it's actually true for both. The same point has to be true for both of them. All right. Easy with that. Hand out your homework. Now, make sure you understand the shading, the consistency, the independence. If you're not sure I'm correct, you will check. Check. Always check. Every time. Okay? Turn them off. You turn them off.